Underreported perspectives on the OceanGate Titan implosion. In this video, we will examine some of the expert reactions and criticisms that have emerged in the aftermath of the implosion of the Titan submersible, as well as some insights that may help us understand the cause and consequences of the implosion. Let's dive into this matter and live a submersible, but with verified facts and uncommon angles to the story, there would be no implosion. It all boomeranged on 18 of June 2023, when the horrific accident occurred in the North Atlantic Ocean, near the site of the Titanic shipwreck. A submersible craft called the OceanGate Titan, carrying 5 passengers, imploded under the immense water pressure and sank to the bottom of the ocean, just like the Titanic it was out to explore. The Titan was operated by OceanGate as a privately funded vessel that aimed to take tourists and researchers to the wreck of the Titanic, more than 3,800 meters below the surface of the Atlantic Ocean. This incident is surprising to many, as the OceanGate Titan was a state-of-the-art submersible designed to explore the depths of the ocean and offer unprecedented views of the underwater world. Its tough design was supposed to withstand whatever pressure the ocean throws at it without the Titan throwing in the towel. It was part of a mission called the Titanic Survey Expedition, which aimed to document the Titanic shipwreck and its surrounding environment. The tragic implosion of the Titan submersible in June 2023 raised many questions about the safety and feasibility of deep-sea exploration. However, during a test dive on June 15th, the sub lost contact with the surface and imploded. All 5 passengers in the submersible kicked the bucket in the incident, leaving behind a trail of grief and unanswered questions. The 5 folks who were on board the Titan submersible. First up, Hamish Harding. He was born as George Hamish Livingston Harding on June 24, 1964, in Hammersmith, London. Hamish was a British businessman, pilot, and adventurer based in the United Arab Emirates. He founded Action Group and chaired Action Aviation, an international aircraft brokerage company in Dubai. Hamish held 3 Guinness World Records and was quite the explorer, visiting the South Pole, diving into the Challenger Deep of the Mariana Trench, and even traveling into space. Next is the Stockton Rush. Born Richard Stockton Rush IBXI on March 31, 1962, in San Francisco, California, Stockton was an American businessman and engineer. He co-founded and served as the CEO of OceanGate, a deep-sea exploration company. Stockton's career kicked off after graduating from Princeton University, where he worked for McDonnell Douglas as a flight test engineer on their F-15 program. Now, Shahzada Dawood. Born on February 12, 1975, in Rawalpindi, Pakistan, he was a Pakistani-British businessman and philanthropist. Shahzada was the vice chairman of the Engro Corporation and a director of the Dawood Hercules Corporation. He had been with Engro since 2003 and became vice chairman in October 2021. Shahzada's son, Sulaiman Dawood, was a business university student. He had just finished his first year at the Strathclyde Business School, affiliated with the University of Strathclyde, Glasgow, Scotland, when the incident occurred. Last but not least, Paul-Henri Narjolet. Born on March 2, 1946, in Chamonix, Haute-Savoie, France, he was a French deep-sea explorer and Titanic expert, often called Mr. Titanic. Narjolet spent years with the Titanic, participating in numerous expeditions to the wreck and recovering thousands of artifacts. He began his career in the French Navy, specializing in mine clearance, diving, and deep underwater intervention from 1964 to 1986. The incident. According to José Luis Martín, a Spanish engineer and underwater expert who analyzed the available data and footage of the incident, the implosion was likely caused by a combination of factors that resulted in a loss of control and stability of the submersible. Martin theorized that during the controlled immersion of the Titan, which was supposed to descend at a rate of about 100 feet per minute, an electrical fault occurred that left the craft without thrust. This meant that the pilot could not adjust the speed or direction of the submersible. At the same time, Martin suggested that the weight distribution of the passengers and the pilot, who were all seated in the front end of the craft near the viewport, would have affected the longitudinal stability of the submersible. The Titan had a total weight of about 11 tons, but about 400 kilograms were concentrated in the front end. This would have created a tendency for the craft to tilt forward. As a result, Martin speculated that the submersible began to fall headlong towards the seafloor at a depth of about 500 feet. The water pressure at that depth was about 2,500 pounds per square inch, which exceeded the design limit of the Titan by about 500 pounds per square inch. The final moments. What happened in the final moments of the Titan? How did it succumb to the immense pressure of the deep ocean? And what are the implications for future submarine technology and tourism? Martin estimated that it took between 48 to 71 seconds for the submersible to reach its crush depth, which was around 6,000 feet. During this time, he believed that the passengers were aware of their impending doom and experienced terror, fear, and agony. He based his assumption on the audio recordings from inside the craft, which captured screams, prayers, and cries for help. He also noted that there was no evidence that the pilot was able to activate the emergency lever that would have dropped weights from the bottom of the craft and allowed it to return to the surface. Martin described the implosion as a violent and instantaneous event that would have killed all 5 passengers instantly. He said that it was like a bomb going off inside a tin can. He added that there was no chance of survival or rescue for anyone inside. Additionally, he determined that the implosion itself would have lasted only 0.2 seconds, releasing a substantial amount of energy, equivalent to 56 kilograms of TNT. Expert reactions. Dave Corley, a former U.S. nuclear submarine officer, explained that when a submarine hull collapses, it moves inward at about 1,500 pint/hour, 2,414 km/h. That's 2,200 far, 621 meter per second. He said that the implosion would have created a shockwave that would have instantly killed anyone inside the sub. He also said that the implosion would have been very loud and would have been detected by sonar systems around the world. Stephen Williams, a professor of marine robotics at the University of Sydney, expressed concerns about a potential catastrophic failure of the Titan sub. He suggested that such failure could be attributed to various factors like a leak, power failure, or even a small fire from an electrical short circuit affecting the sub's electronic systems. The worst-case scenario, according to Williams, involves a breached pressure hull, leading to a catastrophic implosion. Frank Owen, a retired Royal Australian Navy official and a project director for submarine escape and rescue, suggested that one scenario for the Titan sub's situation could be that it is still intact with passengers alive. However, it may have become stuck near the bottom of the ocean, potentially entangled in the wreckage of the Titanic, which is situated at a depth of about 12,500 feet. Owen emphasized the dangers of the debris surrounding the Titanic's wreckage, stating that there are parts of it all over the place. It's dangerous. Alistair Gregg, a professor of marine engineering at University College London, expressed a bleak prognosis for the Titan sub in the event of a leak in the pressure hull. If the submersible is unable to return to the surface on its own, options are limited. Even if the vehicle remains intact, being beyond the continental shelf poses challenges, as there are very few vessels capable of reaching such depths, and sending divers becomes an impractical option. Critics. Concerns were raised over the Titan's experimental design and the carbon fiber material used to build it. The Titan was touted as a revolutionary submersible that could withstand pressures up to 6,000 meters deep. It had a spherical titanium hull that housed the crew and passengers, and a cylindrical carbon fiber section that contained batteries, thrusters, and other equipment. The carbon fiber section was supposed to be lighter and stronger than steel, but also more flexible and resilient to cracking. However, former employees of OceanGate have raised concerns about the thickness of the Titan's hull, suggesting potential safety issues. According to them, the hull was only 12 millimeters thick, which they considered too thin for such a deep dive. They also claimed that OceanGate did not conduct enough tests or inspections on the hull before launching it. They said that they had warned OceanGate about the risks of using carbon fiber, but their concerns were ignored. An Irish engineer questioned the structure of the OceanGate Titan submersible after it imploded in June. John O'Donnell, who has worked on several submarine projects, said that he was surprised by the design of the Titan. He said that he had never seen a submarine with a carbon fiber section between two metal sections. He said that this could create stress points where different materials meet. He also said that he was not convinced by OceanGate's claim that carbon fiber was stronger than steel. Insights: the U.S. Navy detected sounds consistent with an implosion shortly after the sub lost contact during a descent to the Titanic wreck. The Navy's sound surveillance system, SOSUS, which monitors underwater activity around the world, picked up two loud noises at around 9:51 p.m. local time on June 152. The first noise lasted for about 1 second and was followed by a second noise about 2 seconds later. The Navy estimated that the noises came from a location about 370 miles south of Newfoundland. Titan's hull is believed to have collapsed as a result of enormous water pressure. The vessel was so deep that the amount of water on it would have been equivalent to the weight of the Eiffel Tower, tens of thousands of tons. The pressure at that depth is about 400 times greater than at sea level. The hull was designed to resist such pressure by distributing it evenly across its spherical shape. However, if there was any weakness or defect in the hull, such as a crack or a dent, it could have triggered a catastrophic failure. The vessel is likely to remain on the ocean floor indefinitely. The implosion would have reduced the sub to small pieces of debris that would be scattered over a large area. The depth and darkness of the water would make it very difficult to locate and recover the wreckage. The water temperature at that depth is also very low, about 1 degree C, which would slow down the decomposition of any organic matter. The sub may also be covered by sediment over time. Any investigation is sure to focus on the carbon fiber midsection of the Titan sub. The carbon fiber section was the most innovative and controversial part of the sub's design. It was also the most vulnerable to damage from external forces such as collisions or entanglement. The carbon fiber section may have been compromised during the dive, either by hitting an obstacle or by being squeezed by the water pressure. This could have caused a breach in the hull that would have allowed water to flood into the sub. Please note that these are the views of the experts and critics, and the actual cause of the implosion is still under investigation. OceanGate has not released any official statement or explanation about the incident. The company has said that it is cooperating with the authorities and conducting its own internal review. OceanGate has also expressed its condolences to the families and friends of the victims. Conclusion: the OceanGate Titan implosion was one of the worst disasters in ocean exploration history. It claimed the lives of 5 remarkable individuals who had dedicated themselves to advancing human knowledge and curiosity. It also dealt a major blow to ocean exploration efforts and raised questions about the safety and feasibility of commercial dives to extreme depths. However, despite this tragedy, we should not lose sight of the importance and value of exploring our oceans. The oceans cover more than 70% of our planet and hold countless secrets and wonders that await discovery. They also play a vital role in regulating our climate and sustaining life on Earth. We should honor the memory of those who perished in this incident by continuing their legacy of ocean exploration. We should also learn from their mistakes and improve our technology and protocols to ensure that such accidents never happen again. They were pioneers who dared to go where few had gone before. They were explorers who sought to expand our horizons. They were heroes who paid with their lives for their passion. They will not be forgotten.